Hey guys, let's talk about finding zeros of polynomials, okay? And we're going to do this first using the remainder and factor theorem. So here's the remainder theorem. Suppose f is a polynomial function. If f of x is divided by x minus c, then the remainder is always f of c. So let's do an example of this. Purple's good. We're going to find the remainder of f of x, which is x cubed minus 4x squared minus 5. And we're going to divide this by x minus 3, and then b is going to be divided by x plus 2. Okay, so first we have to talk about how to do synthetic division, because that's how I'm going to do this. So with synthetic division, we always use the coefficients in front of our variables. And you want to make sure that it is in descending order. So like here we have x cubed minus x squared, but we are missing our x term, so we'll put a 0 in place of that, okay? And then here we have x to the 0 power, which is just 1, so that gives us our constant. So let's start. In front of x cubed, we have a 1. In front of x squared, we have a negative 4. Like I said, we have no x, so we're going to put a 0, and then here we have a negative 5. So that's all of our coefficients. Now, we are going to be dividing it by x minus 3. Let's take a little break over here and talk about that. So we have x minus 3 is what we're dividing, but we always put what we're dividing by in a little house or a little box over here to the side, and we change the sign on this guy. The reason for that is because if we set this, oh my goodness, Shelly, equal to 0 and solve, we're going to add 3 to both sides, right? So x then equals positive 3. So the positive 3 is what goes in here. A faster way to think about it is just remember that he is always a liar and change his sign to 3, right? That's the faster way to do it, but you could always solve it. That's perfectly fine. Now, underneath your coefficients, you're going to draw a line, but drop it down a little bit because you're going to have to write some numbers in here. Okay, the reason why we drop it a little bit is because this guy's going to come down here. My college algebra teacher always used to say, we have to drop this one like he's hot, you know, like this Snoop Dogg song. But I can't sing like Snoop, so I won't do that injustice to you guys. Now, above the line, it's always addition. Below the line is always multiplication. So we're going to take 3 times 1. That's going to give us 3. Negative 4 plus 3 gives us a negative 1. Now, 3 times the negative 1 gives us a negative 3. Okay, so we're going to bring our negative 3 down. 3 times the negative 3 gives us a negative 9. Well, this is the last number that there is, so we always make a line here because this is our remainder. Negative 9 plus a negative 5 is a negative 14. So our remainder, which is what it asks for, is going to be negative 14 over x minus 3. You always put the remainder over what you divided it by, okay? Okay, now let's do b. So b, we're still going to have the same coefficient, so it's going to be 1, negative 4, 0, and negative 5. But this time, in our little box, we're going to have a negative 2, okay? So we're going to drop this guy like he's hot. Negative 2 times 1 is going to give us a negative 2. This is going to give us a negative 6. Remember, we multiply it this way. Negative 2 times negative 6 is a negative 12. I meant positive all day long. So this is going to be a positive 12. Negative 2 times a positive 12 is a negative 24. So our remainder is a negative 29. So remainder, negative 29 over x plus 2. Okay? Now let's look at the factor theorem. So suppose f is a polynomial function, then x minus c is a factor of f of x, if and only if f of c equals 0. Okay. So the factor theorem actually consists of two-part statement. It's an if and only if statement. That means one can only exist if the other is true, right? And it goes both ways. So if f of c equals 0, then x minus c is a factor of f of x. And if x minus c is a factor of f of x, then f of c equals 0. So one is dependent on the other, right? And then the other is dependent on the one. So they go both ways. One cannot exist without the other. That's what if and only if means. Okay, let's look at this. So we're going to use the factor theorem. I just picked the wrong one. Use the factor theorem to determine whether the function f of x equals 2x cubed minus x squared plus 2x minus 3 has the factor x minus a and x minus 1 and x plus 2. Okay. So what this is asking is if we divide f of x by x minus 1, if it gives us a 0 remainder, then this is a factor. And if we divide it by x plus 2 and it gives us a 0 remainder, then x plus 2 is a factor. Okay, so that's what we're shooting for, is a 0 remainder. Okay, so again, we're going to start with the coefficient. So our coefficient is going to be 2, and we also have to look if it's in descending order. So 3, 2, 1, 0. We are. Now 2, negative 1, 2, negative 3. Those are coefficients. And a, we're going to start with positive 1 in the box, right? Because he's a liar and we switch him. So we bring 2 down. This is going to be a 2. This is going to give us a 1. 1 times 1 is 1. Now we add these. Remember, up here it's always add. Down here it's always multiplication. 1 times 1 is 1. Add these, it's 3. 1 times 3 is 3. Negative 3 plus 3 is a 0. So yes, x minus 1 got a remainder. So yes, this is x minus 1 is a factor. Okay, now let's do the other one. So we know that x plus 2 is what we're dividing into it, so it's going to be a negative 2, right? He's a liar, we change. Same coefficient, so it's going to be 2, negative 1, 2, negative 3. Drop this guy like he's hot. This is our multiplication, this is our addition. Negative 2 times 2 gives us a negative 4. Add those, get a negative 5. Positive 10. This gives us 12. Well, negative 2 times a positive 12 gives us a negative 24. Add these two together, that gives us a negative 27. This does not equal 0, so that implies no. X plus 2 is not a factor. So this. Okay, so that's how you use the factor theorem. Here's a neat little tip. Number of zeros. A polynomial function cannot have more real zeros than its degree. So like if you have a polynomial function that's like x squared. Let's look at these up here. We have an x squared? No, these are all x cubed, so let's just do x cubed. 2x cubed minus x squared plus 2x minus 3. We know that this is a degree of 3. So at most, it could have 3 real answers. Alright, so at most it could have 3 solutions. How about that? Okay. That's a pretty handy little tip right there. Okay, now let's look at the rational zero theorem. The rational zero theorem states that if a polynomial, and this is just the math definition of a polynomial, okay, it just means any coefficient in front of x to any number, and then it just descends in order, okay, has an integer coefficient, then every rational zero of f of x has the form p over q, where p is the factor of the constant term, a naught, right, that's back here. And q is a factor of the leading coefficient, an, and he's up here. When the leading coefficient is 1, the possible rational zeros of the factors of the constant term. I didn't read that right. When the leading coefficient is 1, the possible rational zeros are the factors of the constant term. Yeah. So if the coefficient in front is just 1, then the possible rational zeros are just the possible factors of the constant. Okay. Given the polynomial function f of x, use the rational zero theorem to find the rational zero. So first thing that you're going to do is you're going to determine all factors of the constant term, and then all the factors of the leading coefficient, okay? Then determine all the possible values of p over q, where p is the factor of the constant and q are the factors of the leading coefficient. Be sure to include both positive and negative candidates. And after you figure all of those out, then just plug those in to your function and see which ones give you a 0. Okay? The ones that equal in 0 will give you that will be one of your zeros, and then you can do long division to figure out, or synthetic division to figure out your others. Okay? So first, I just want you to list the possible rational zeros. Okay, so we're going to look at P and Q. So P equals 6 and Q equals 2. So 6, we're going to list plus minus 1, plus minus 2, plus minus 3, and plus minus 6, right? That's all the factors of 6. But you always got to remember both the positive and the negative, so I always put plus minus in front of both. Now, Q is your 2, so we're going to have plus minus 1 and plus minus 2. I should put a commas in front of between all those. Now, that was determine all the factors of your constant term and all the factors of your leading coefficient. So that was number 1, right? Now let's do number 2. Number 2 is that we're going to determine all the p over q's. Okay. So I just start by starting with my number 1 here. So plus minus 1 over 1 is 1. Plus minus 1 over 2 is 1/2. Okay, so that I'm done with my 1 now. Now I'm going to start with my 2. 2 over 1 is 2. 2 over 2 is 1. So now I'm done with my 2. 3 over 1 is 3. 3 over 2 is 3/2. So I'm done with my 3. And then I'm going to go down here. Plus minus 6 over 1 is 6. And 6 over 2 is 3, which I already have, so I'm done, right? So we have 1, 1/2, 2, 3, 3/2. Oh, my 6 will fit up here. I was just freaking out and thought he wouldn't. There we go. So that's all my p over q. Those are all my possible rational zeros. So now we start by plugging them all into my f of x. Different color, please. So I'm going to have f of negative 1, f of 1, f of negative 1/2, f of 1/2. f of negative 2, and f of 2. We're going to see what all of these equal. And then now that's those. So we'll start over here. F of negative 3, f of 3. F of negative 3 halves, and then f of 3 halves. F of negative 6, and f of 6. Okay. So you could plug all these in and do them by hand, or you could do it by calculator. And I'm going to see if I can get my calculator up, hopefully. Sometimes this works. Okay, so I'm going to have to leave this small. But anyway, so what we're going to do is, oh man, that is not what I wanted to happen. Okay, so we're going to take, and we are going to try to make this work. We are going to say, turn our calculator on. There we go, and clear it. Clear. Now, we're going to save -1, store x. And then you hit enter. And now -1 is going to be stored as your x, okay? And we're going to put in our function. So we're going to say 2x cubed. And go over. Plus 11x squared. Get out of that. Minus 7x. Minus 6. Now when I hit enter, it's going to give me the value for -1. And that's 10. So this is going to equal 10. When I write this down, it's going to make my calculator disappear. So this is going to be a long, tedious process. Forgive. But this is going to be 10. Now I'm going to pull my calculator back up. And we're going to store 1 for x. That didn't work out right. Clear. 1 store x, enter. So now 1 is in here, and if we go up and grab our function again and hit enter, we're going to see that this gives us 0. So for f of 1, it's going to be 0. So I have stored that into my calculator for each of these. So instead of keep on grabbing my calculator for each one, I'm just going to write down what it is. But I did store okay, so -1/2 give me 0 as well. +1/2 gave me a -6.5. -2 gave me 36. Please check these numbers in your calculator because I am human and do make mistakes. If I make a mistake, you can email me and let me know, okay? So +2 gave me a 40. -3, I got 60. +3, I got 126. -3/2, I got 22.5. +3/2, I got 15. Yes. -6, I got 0. And 6, I got 780. So my possible zeros are 1, -1/2, and -6. It's kind of not in the right order, is it? But anyway, they're so all over the place. But there's my possible zeros. Okay? Right on. So now let's use the rational zero theorem to find the rational zeros of 2x cubed plus x squared minus 4x plus 1. So on this one, On this one, our P is 1 and our Q is 2. So we have plus minus 1. This is plus minus 1 and plus minus 2. So P over Q is plus minus 1 and plus minus 1/2, right? 1 over 1 and 1 over 2. So then we can plug those in. So we're going to have F of negative 1, F of 1, F of negative 1/2, and F of 1/2. And again, I programmed these into my computer, or into my calculator, right? So I programmed -1, store X, and then I put my function into my calculator and then hit enter, and I got 4. Then I did 1, store X, enter, scrolled up, got my function, hit enter twice, and then that gave me 0. I stored -1/2 X, enter, scrolled up, got my function, hit enter twice, and I got 3. And then I stored 0.5, store X, I guess, enter, and scrolled up and got my function, hit enter twice, and this gave me a -0.5. So my only 0 was 1. So now we need to do long division. No, synthetic division. I don't know why I keep saying long division. Let's do synthetic division. So we know that our 0 is 1. So this is what's going to go in our box, okay? And then now we get our coefficients, which are going to be 2, 1, -4, and 1. Again, we drop this one like he's hot. Multiply here and add here. So 1 times 2 gives us 2. 2 plus 1 is 3. This one's multiplied down here. So 1 times 3 gives us a 3. -4 plus 3 gives us a -1. 1 times a -1 is a -1. This is our remainder, which is 0. Okay, so this is something else I think I haven't told you guys about synthetic division, is that since we started with x cubed, this was our coefficient for x cubed, right? But every time we drop below the line, we drop this now as x squared, right? Because we factored 1 into it, so we go down an x. So now this is 2x squared minus 3x minus 1, right? And then that's our remainder was 0. So we could set all this equal to 0, and we can solve for this. So our factors now are going to be x minus 1, and 2x squared minus 3x minus 1. But we could factor this guy, right? So if we would use the AC method, we know that 2, that's going to give us a 2, and the factors of 2 are 1 and 2. Factors of 2 that are going to different signs. Let's see, different signs. It's supposed to be subtract to give you 3. And this sign says that the larger we get the plus. So this would be plus 2x squared plus 2x minus 1x minus 1. these combined do not make 3, right? That makes 1x. So we're going to have to use the quadratic formula. Okay, so A equals 2, B equals 3, and C equals -1. Okay, so the quadratic formula is x equals -b plus minus the square root of b squared minus 4 times a times c, all divided by 2 times a. So now let's just plug these in and see where we go. So we're going to have x equals negative, and our b is 3, plus minus the square root of 3 squared minus 4 times a, which is 2, times c, which is -1, all over 2 times a, which is 2. So this is going to give us -3 plus minus square root of 9. -4 times 2 is 8. That would be plus 8 all over 4, which is going to be -3 plus minus square root of 17 over 4. Okay, so we can put this into our calculator and see that x is going to equal two different numbers. That is going to be -3 minus square root of 17 divided by 4, which is going to be, I should put approximately, not equals, sorry, approximately 1.78. And then it's also going to be -3 plus the square root of 17 divided by 4, which is approximately 0.28. So we have our x's, so x is, I'm just going to put equal to, you guys cut me some slack there please, 0.28, 1 and 1.78. I think it was -1.78 though, if I'm not correct. Yeah, -1.78, sorry, because that negative there. So if we did a set, it would be -1.78, 0.28, and 1. This one's kind of written backwards, sorry. I missed that negative sign. Okay. Alright, that's it for that one. I think we have one more we're going to see using the calculator, so let's do that real quick if we can get it all together on this one sheet. So enter the function into y equals, right, and press second trace. Let's see. I take this little, yeah. Okay, y equals. So let's do x to the 4th. I'm sorry, it's such a long video, guys. 5x cubed. Oops. Plus minus 2x squared plus 60x minus 168. Okay. So now, the pressure of being able to see what I'll just read it to you. How about that? So we put this in here, and then we're going to put second trace. And then we go down to number, oh, no, let's go back here. And then we want to hit graph, so we can see our graph. We can see where it crosses. Okay, so now we want to do second trace. And we're going to go down to 0. And of course we want left bound, but this time we can't really see our cursor, so we have to pay attention to where our bounds are. So we're going to start going to the left, hopefully. And this is 1, 2, 3, 4, 5, 6, close to 7, so we have to watch where our guy here is. So when we get close to -7, we have to be paying very close attention. So that's far enough. We'll hit enter, and then we want to go, it's marked here, so we want to go below 7. I'm going to say enter. Enter. So Negative 7 is one of ours, so that is one of our zeros. And we want to do it for the next one here. So we'll just do second trace, go down to 0, and then we have to watch our bound again here. And it looks like we're close to positive 2, so. And we want to go left bound so it's below it, so I'm going to leave it there. And then I'm just going to go above it there. So, and it is 2. So we see that negative 7 and 2 are 2 of our zeros. So I'm going to go ahead and put that down. So x equals negative 7 and 2. Okay. So we know that. So we can go ahead and just start with our synthetic division. We have 4, 3, 2, 1, 0. So we're good. So our coefficients are going to be 1, 5, negative 2, 60, and negative 168. It doesn't really matter which 0 you use. If you use the 2 or the negative 7, it's about the same either way. I did them both ways, so just to be sure, but like I knew it was, just so that if there are questions from any of you guys, I've done it both ways. So I'm going to start with the 2 if that's okay with you guys. So this guy gets dropped. So 2 times 1 is 2. Remember, this is addition. So then this is going to be 7. 2 times 7 is 14. This is going to give us a 12. 2 times 12 is 24. So this gives us an 84. And 2 times 84 is 168. So this gives us a 0 for our remainder. Okay. Now we can just jump straight into the other one. No sense in doing anything else. We'll just put our negative 7 here. Drop this guy. Negative 7 and 1 is a negative 7. This is going to give us a 0. Negative 7 times 0 is 0. This gives us a 12. And negative 7 times 12 is a negative 84, which gives us a 0. And this time, this is our remainder, right? Well, we started up here. This was our x to the 4th power, which means this is x to the 3rd power. This means this is x squared. So now we have x squared plus 12 equals 0, right? So now we just need to factor that or solve for that. So we would move this guy over, so it's going to be x squared equals negative 12. And we want to solve for that x, so we would take the square root of both sides. Don't forget your plus minus because it is an even root. So this is going to be x equals. Alright, we had to pull our I out. No, we need to put our plus minus first. And then our I. And this is going to be the square root of 4 times 3. This could be 2i square roots of 3. Or, I like to write it better, like plus minus. Well, we probably should do them separate. Well, let's do it plus minus first. 2 square roots of 3i, right? I goes in the back. And then you can write it as 2 separate. Negative 2 square roots of 3i, and then 2 square root of 3i. Okay. So, all of our zeros would be, we did a set, we'd have negative 7, negative 2 square roots of 3i, and then, I don't know, 2, and then 2 square roots of 3i. How about that? Y'all like that? Look good to you? And we had the 4th degree, so we expected 4, and we got 1, 2, 3, 4. So there you go. Okay, I'm going to stop here because that is a ridiculously long video, and I apologize for that. I hope you guys have the very best day.